Have you ever looked up at the night sky and wondered what secrets are hidden in those tiny points of light? Well, one of our closest neighbors, the smallest planet in our solar system, Mercury, has been holding on to a colossal secret. How could a planet so tiny, barely larger than our own moon, possess a core so massive it defies everything we thought we knew? This is the story of how we're finally starting to unravel Mercury's biggest mystery. For decades, Mercury has been a puzzle for astronomers. We knew it was a dense, iron-rich world. The prevailing theory, born from data gathered by missions like Mariner 10 and Messenger, was that Mercury's core was a massive, molten ball of iron, making up a staggering 60% of its entire mass. To put that in perspective, Earth's core is only about 30% of its mass. This led to some wild theories about Mercury's past. One popular idea was that in its youth, Mercury was a much larger planet. Then a catastrophic giant impact with another protoplanet blasted away most of its original crust and mantle, leaving behind the oversized, dense core we see today. It's a dramatic, blockbuster-worthy origin story, but what if it wasn't the whole picture? Another theory suggested that as the young sun heated up, its intense radiation and solar winds literally boiled away Mercury's outer layers. Being the closest planet, it would have taken the brunt of this solar furnace, stripping it down to its dense metallic heart. Both of these theories painted a picture of a violent and chaotic past for this little world. They were our best guesses, logical conclusions based on the data we had. But science is a process of constant questioning and refinement, and what we needed was a new way to look at Mercury, a tool powerful enough to see what others couldn't. Enter the James Webb Space Telescope. You've probably heard about the stunning images of distant galaxies and nebulae it's been capturing. But Webb isn't just for looking at the far reaches of the universe. It's also an incredible tool for studying our own solar system, offering a level of detail we could only dream of before. The Webb telescope observes in the infrared spectrum, which is key to unlocking new types of information about planets. It can analyze the heat and chemical composition of planetary surfaces and atmospheres in unprecedented detail. And when Webb turned its powerful golden eye toward Mercury, it was about to rewrite the story of the swift planet. So, what did Webb see that changed everything? Instead of directly looking at Mercury's core, which is impossible, scientists used Webb to meticulously study its surface. They were looking for something specific, subtle variations in the chemical makeup of the planet's crust. Why? Because the composition of the crust can give us major clues about the mantle and core beneath it. The theory goes that if a giant impact had stripped Mercury's original crust, the new reformed surface would be relatively uniform. It would be made of material that welled up from the mantle after the cataclysm. But Webb's highly sensitive instruments, particularly its mid-infrared instrument, or MIRI, found something else entirely. The surface of Mercury isn't uniform. Instead, Webb detected distinct regions with different chemical signatures. It found areas rich in certain types of rock that are difficult to explain with the giant impact theory. These surface rocks, known as low reflectance material, seem to be remnants of Mercury's original primordial crust, a crust that, according to the impact theory, shouldn't even exist anymore. This was the first major crack in the old story. The discovery of this ancient crust suggests that Mercury didn't suffer a single, cataclysmic mantle-stripping collision. If it had, this original crust would have been completely obliterated or buried under molten rock. The fact that patches of it are still there on the surface implies a much less violent history. So, if a giant impact didn't create Mercury's enormous core, what did? The new data from Webb points toward a different, more nuanced explanation. The composition of this ancient crust hints that the materials that formed Mercury in the early solar system were simply incredibly rich in iron to begin with. This leads us to a new, fascinating hypothesis. Perhaps Mercury's massive core isn't the result of having its outer layers stripped away. Perhaps it was just built that way from the very beginning. The early solar system was a chaotic place with materials distributed unevenly. It's possible that the region where Mercury formed was naturally concentrated with heavy elements like iron. As the planetesimals in this region clumped together to form the planet Mercury, they were already carrying an unusually high percentage of metal. So Mercury wasn't a victim of cosmic violence. It was simply born from iron-rich building blocks. This new theory doesn't just change our understanding of Mercury. It changes our understanding of how planets can form throughout the galaxy. It suggests there's a wider variety of planetary formation processes than we previously imagined. Not every rocky planet needs to follow the same recipe as Earth or Mars. Some, like Mercury, could form in unique pockets of the protoplanetary disk, resulting in exotic compositions. Webb's findings open up the possibility that out there, among the countless exoplanets, there could be many more super-Mercuries, planets with massive iron cores, formed not by destruction, but by their unique birthright. The story of Mercury's core is a perfect example of the scientific process in action. We start with a theory based on the best available evidence. Then a new technology, a new tool like the James Webb Space Telescope comes along and gives us a sharper view. It reveals details that challenge our old assumptions and force us to think in new ways. The mystery isn't completely solved, of course. Scientists will continue to analyze the Webb data and plan future missions to test this new hypothesis. Missions like the European Space Agency's Bepi Colombo, which is currently en route to Mercury, will provide even more crucial data to help us piece together the planet's full story. What an incredible journey of discovery. From a planet defined by a violent past to one with a unique and special origin. It just goes to show that there are still so many secrets hiding in plain sight. Right here, in our own cosmic backyard. The universe is constantly surprising us, and with amazing tools like the Webb telescope, we're ready to listen to the stories it has to tell. Thank you so much for joining me on this deep dive into the mysteries of Mercury. If you found this as fascinating as I did, don't forget to hit that like button and subscribe to the channel for more explorations into the wonders of our universe. Let me know in the comments what planetary mystery you'd like us to investigate next. Until then, keep looking up.